Let's look at another type of problem. In this case, we have a question, so remember it can be a question or a statement. Our big deal is making sure that we can identify what our given is and what it is that the statement or question is asking us to find. So it states here that how many moles are in 3.75 times 10 to the 25 atoms of iron metal? Our given is a 3.75 times 10 to the 25 atoms. And what we're trying to find out is how many moles does that mean. So I like to go ahead and pull that information down. So our given is 3.75 times 10 to the 25 atoms. Atoms because we're talking about an element, just elemental iron. So we use the descriptor atom for that. And what we're trying to find is, what does that mean in moles? Okay? So we need a relationship between atoms and moles. And we get a relationship between atom and moles using Avogadro's number, which is for every mole of any substance, there are 6.02 times 10 to the 23 particles of that. Okay, in this case, we're using a specific term called atoms because a particle is general for any type of substance. Atom is describing something, in this case, that is iron. All right, so we are going to start our problem with our given. And this time we want to cancel out Avogadro's number. And we're moving to moles, so moles should be in the numerator. I'm sorry, y'all, it's this little program. I need to find a different one. There we go. All right, so we know we're going to cancel out atoms here. We're going to be left with moles. And we're dealing with iron metal. And I'm going to divide those two. I hope you notice that we do have more than 1 mole of our iron here because, see this times 10 to the 25? We know that in 1 mole of anything there's times 10 to the 23, so we should have some answer that is greater than 1 mole. This is just a way for you to look at your problems and feel confident about your answers that you are deriving, okay? So it's always good to sort of examine your data and make some inferences about what you believe the outcome might be based on things that you know about numbers. All right, well, we did get a number greater than 1, didn't we? So we have 62.292, yada, yada, yada. So we need to round that to 3 significant figures, which is about the common amount of significant figures for most of our problems. And that should be 62.3 moles of iron metal. Thank you.